whereas the non-slums, slums with little shadow are very congested areas. And here you can see that non-slums with more vegetation, whereas slums with lack of vegetation or sometimes little or less vegetation. And mostly they are located in the vulnerable areas like close to the railway lines, transportation lines, or along the slopes, or along the major highways, or along the river banks. You can see in the image, say near the canal water source, near the river, near the major highways and the slopes. So other than this contextual or spatial characteristics, even spectral characteristics also can help us to differentiate the slums from non-slums. You can see here GLCM textual measures, which shows the slum area as well as non-slum areas. So all these informations can be put together to detect the slums. Here again, I didn't use the pixel-based approach, we used object-oriented approach, which can give a better results when comparing the traditional pixel-based approaches. Here the slums are extracted from QuickBird data. First, the basically multi-resolution segmentation has taken place. We differentiated, got the basic image meaningful objects. That objects are divided again into, classified into built-up and non-built-up. Then again the built-up areas we classified slums and non-slums. So we used so many features for developing the rule set, including brightness, which helped us to differentiate the shadow and non-shadows. Shadows are mostly close to the high-risk structure, that means the non-slum areas. Green ratio, the presence of vegetation, and mean difference to the scene, texture-based measures, and contextual information like distance to water body, distance to transportation lines, and relation to the object borders. All these features helped us to develop the rule set. By developing this rule set, we can classify the image into slums as well as non-slums. And when you talk about accuracy assessment, it has been using that ground-based sample measures. We compared the classified image, almost 87% accuracy it has given. So you can see this is the Pune city map. This center part of the city has been taken for this assessment, and this is the original image of QuickBird, and this is the classified image. But here we have some problems in the inner city. That is the old indigenous city, where it is again it's a compact with less vegetation and all those things. So it may give a false positives. So we can work out by cleaning that rule set or redefining the rule set in a better way. So this is the result we got it. So this shows that by using remote sensing, high spatial resolution data, we can map the slums, which is essential to improve the slum conditions and slum dwellers' needs. So today's towns are tomorrow's cities, and today's cities are the future of mankind. Let us work together for the better world. Thank you.
Thank you very much. Since the time is running, maybe people who is interested to directly go to her to ask some questions. Thank you very much.
Thanks.
I would like to move on to the next speaker. Are you Huang from China? Are you here? No? Okay, then we will go to the next speaker, Dr. Hiroyuki Miyazaki from Japan. The title is Automated Construction of Coverage Catalogs of Astro Satellite Image for Urban Areas of the World. Please, Miyazaki.
Okay. Thank you for introduction. My presentation is about automated construction of coverage catalog of Astro satellite images for urban areas of the world. Firstly, I'd like to introduce my background. There are several needs on the urban analysis using tens of meter satellite data such as Landsat and Astro and recently Isprs. The most representative work is Angel's work in which 120 cities were analyzed by using Landsat data. Then, as you know, choosing selecting satellite data is very time-consuming because of cloud contamination. Also, some large cities can be over the extent of the satellite data. So we have to consider the good combination of satellite data over the cities. Also, consideration of cloud contamination. Then, in this study, I proposed a method to choose a good combination of cities of the world. And also, I conducted this method on 3,342 cities of the world. Then I will explain the overview of the method. Firstly, I defined an urban extent at a certain extent. For example, Tokyo or Melbourne or Beijing or home for the over the 3,000 cities over the world. Please find detail about the definition in my paper. And then this spatial extent data of the urban extent is overlaid with satellite image metadata of the satellite metadata database. And then a set of candidate satellite data is selected, and then these are ordered by quality of satellite data, such as cloud contamination. Then here these set of satellite data is tested regarding the coverage of on the urban extent. For example, in this case, if we reject a extent of A, satellite data A, the urban extent coverage for the urban extent is still completed like this. But if B is rejected, there is uncovered segmentation around here. Then we can decide A is not necessary, B is necessary. Then by testing such a procedure for all of the satellite data, we can acquire a set of combination for this urban extent. Here is an example of the result. Result of Tokyo, Sao Paulo, Cape Town, Najaf. Then you can see a good combination of the satellite data for these cities over the extent of source-wise of the satellite data. This is also a good example of the result. These are not a good result. For example, Yamoussoukro has a haze, bad images with haze. Also, La Romana has densely cloud contaminated. And also, in Keren, there is some part, no satellite data is identified. Also, Rockford had a snow cover like this, and Ganoa is densely cloud contaminated. Then, such a bad combination had about 30% of the combination of the cities. Then I had a trial to make a combination by manual. Then I identified some good combinations like these. Then there is much space to be improved on the algorithm as I shown. Then, such as cloud contamination, assessment of cloud contamination, also assessment of satellite data. Here is current status of the result. You can see I will demonstrate the result with my PC. Then I'd like to conclude my study. I had constructed a catalog of satellite data using the metadata of satellite images. And also, I identified some issues to be improved, such as cloud contamination assessment. Also, pixel by pixel assessment would be improved. The combination of the combination of the satellite data. Thank you for kind attention.
Thank you very much. I'd like to move on to the last speaker, Dr. Mariela Sotoberelov from Australia. The title is A Glimpse into the Past, Using Historical Aerial Photography to Map Seagrass Distribution Dynamics in Port Phillip Bay, Victoria, Australia. Please.
Thank you. This short presentation falls within the topic of ocean resources, which is one of the focus areas of this poster session. And it specifically looks at seagrass change in the Port Phillip Bay over the last 75 years. And the Port Phillip Bay is the largest bay in Victoria, which is the state that we're in. And the Port Phillip Bay is the bay that's surrounding the city of Melbourne. So a bit of background first. Seagrass habitats are of high ecologic significance. They are also an important economic resource, as for instance, they serve as nursery beds for fisheries. And the literature indicates that on a global scale, seagrass areas have been declining during the last few decades, and obviously this is a cause of concern. This also appears to be the case in Port Phillip Bay, according to some studies that have looked at seagrass change during the first decade of the 21st century. So to investigate this recent decline in seagrass areas, we did an in-depth assessment of 3 sites within the bay, which are all representative of extensive seagrass areas. And we did this using historic aerial photography. And so our objective was to map seagrass cover over a 75-year period, and in this way see if we could detect spatial and or temporal trends with regards to seagrass change in the Port Phillip Bay. So the first step in our methods, obviously after selecting our study sites, were to look at the image archive, and we went ahead and found all the aerial photographs that we thought allowed us to delineate seagrass areas in detail. And then we went and processed these images, and I won't go through the steps of the methodology, but you can come and talk to us after. But we did do an accuracy assessment on all the images that were post-2008 using underwater video footage, and we achieved an overall accuracy greater than 85%. So we were pretty happy with our results. And I'll just mention that our image database went from the late 1930s until 2011. So our results, here you can see the 3 sites within Port Phillip Bay that were mapped over time. And the first thing that we found was that the 3 areas seem to experience similar trends in terms of seagrass change throughout our study period. We were able to see the recent decline in seagrass that was also mentioned by other studies in our study sites during the last decade. But perhaps more surprisingly was that we found that the present-day low levels of seagrass cover in the bay were not unprecedented. So we found that our earliest imagery actually showed that seagrass cover in the late 1930s was at even lower levels than it is today. So to conclude, I guess what this does is that it highlights the importance of adding a historical aerial photography to understand processes that are occurring today. And if you have any questions, you can talk to me and one of the co-authors who is here and is also an expert in aquatic ecology. Thank you.
Thank you very much. You still have time, so is there any question? Yes, please.
Do you think there was a link between the 1930s and today with the seagrass levels?
Well, seagrass change is driven, decline is driven by human and anthropogenic causes. So it's hard to say it's one thing or another, but it's interesting that they both coincide with periods of extended drought in Australia. So maybe that's triggering other factors that cause it to contract.
Okay, thank you very much.
Thank
Okay,
you.
so I think all the speaker is finished because in this session there's 5 speakers was absent, so I gave you 5 minutes instead of 3 minutes. But I'm sure you still need more time. And usually this is an open session, but as you know, there's only one big, not big, but middle projector on the outside, only one. So it is really difficult to do the interactive session. So I'd like to recommend you to talk to each person to the speaker and then do the further discussion. So I would like to check the speakers. Let's see. Okay. Dr. Endo, the first one, please raise your hand. So stand up please. So he is the first speaker. So if you are interested, please go to him to ask about his presentation. And the next one, Dr. Darvishov. Okay, so he's the second speaker. And then Dr. Nass. So he is the third on red plus, and Dr. Steve. Okay, the next one. And then, let's see, what's this? This is cancelled. Dr. Miyazaki. Yes. And then, Dr. Soto, I'm sorry, pronunciation. And I'm sorry, which one was it? Yeah, from India. This one. I'm sorry. Dr. Shekhar. Yes, so she's there. So if you have questions, please go to her and all the other presenters. Thank you very much for your attendance.